So these arrays of numbers, which we call vectors, so these are coordinates x, y, z, and the corresponding colors, red, green, and blue, are going to become the inputs for our vertex shader. And again, reminder that the vertex shader is going to be invoked for each vertex that we supply. So depending on the size of this array, this is how many times the vertex program is invoked. But we already discussed that the GPU has multiple processing units which will execute these vertices in parallel. So that provides the high speed of execution in the GPU because the vertices are going to be processed in parallel. It is also impossible to tell which one will be processed first and which one is going to be processed next. This is up to the hardware to decide. Basically, when you have just a few vertices, of course, they will all run at the same time. Alright, so the next stage here is to take care of the shaders. We load the two of our shaders, vertex and fragment, so these text files are loaded. Then we compile them separately, then we link them together. We print some diagnostic messages just to be sure that everything is done. In the next step of our program, we need to explain to graphics hardware what is the structure of our inputs. So the structure, we're going to refer to the structure as vertex array. And we have vertex arrays that represent our individual vertex attributes, like this. And so we begin by calling generate vertex arrays. Generate vertex arrays means that we would like to prepare for specifying what is the configuration of our vertices, how we provide all of this information. So notice a little strange style here. Generate vertex array takes address of VAO, vertex array object, which is just a variable that is declared right here. This is an unsigned integer, and this is just a unique identifier that our OpenGL hardware is going to return here. You can generate multiple vertex array objects, so this is why we specify how many we want, and we specify the address. So this could be an array of integers, but we generate only one and it gets populated. Then we say bind, and bind means use this thing that we just generated. So now basically this is just a protocol of preparing to explain how it all is configured and start loading them. Then we say generate buffers. Buffers generally refers to GPU memory. So for the buffers, we use another unique identifier, which is buffer object, vertex buffer object. And again, you can create multiples, you can create more than one. And this is why we pass the address of another unsigned integer, which is also defined as a global variable in this example. And it gets populated with unique variable. Then we say bind buffer, and that means that we're going to use this memory buffer that we just generated. And when we say use, we also specify what kind of buffer it is. There are different kinds of memory buffers available in GPU hardware. So for us, we're going to use array buffers, which is the arrays of these attributes. Right, so next thing is that we would like to specify what is the buffer size that we need. So if you look back at the two arrays, the vertices and colors that we just created, those are arrays of floating points. So we take the size of floating point in bytes. Okay, so this buffer size is going to be counting bytes. And we say that number of vertices is 3, so we have to know how many vertices we're drawing. That the number of components in the vertex array of vertices is 3 for each vertex. So 3 times 3 plus 3 times 4. So here red, green, and blue actually includes the alpha component. So the size, the number of color components is 4. So that's just the example of configuration that we're using. So this gives us an exact number of how many floating point numbers are here in these two arrays, and we multiply it by the size of floating point number, which gives us how many bytes these two arrays are occupying. The next stage is that we say let's allocate the array buffer. However, so we specify this buffer size that we just computed, and we again use this type of buffer, array buffer. This call requires this type of specification, but this null tells the hardware that we're not yet giving any data, that we're just reserving the specific size. Static draw is the drawing mode that we're not expecting this data to change very dynamically. Basically, once loaded into GPU memory, it should be retained essentially for the duration of our program execution. And now we need to prepare to load the vertex points. Right, so these things right here, we now want to load them. So right here, we call this buffer subdata, which basically is starting to populate this buffer of this size with some data. So what this call is specifying is that we set the offset at 0. Okay, so essentially what happens is that this buffer size has been allocated for us, right? So this buffer size is of a certain size, and it's ready to accommodate all the floating point numbers that we're just about to load. We set offset to 0, and we specify that we're going to start at 0 location right here of this buffer. Now this buffer is actually in graphics in GPU memory, and then we specify how many bytes we just computed how many vertex bytes we have, and so this is the vertex bytes is going to be how many bytes, right? So this right here. And the vertex bytes we compute 3 by 3 by size of. So this is basically the first part, the number of vertex bytes. And we say that we would like to load here our array of vertices. So that array of all vertices that we have gets loaded into this area. So basically, so this area is populated with the floating point numbers. The next step is that we say, okay, so we are going to change our offset now to the position of right next after the vertex bytes. Okay, so let's scroll this down a little bit more. So the next step is that, again, I'll just redraw this buffer in memory. And now we change the offset over here. This offset is going to be changed to go past the vertex bytes, right? So the vertex bytes already have been loaded, and now this offset points to the next location after them. And now we also compute how many color bytes we have. So we say 3 times 4, because we have RGBA, that's 4, 3 vertices, and this is the size of the float. So basically we say that this many bytes we're now going to populate with our array of colors. Right? So array of colors is going to be populated right here. So this is how we make these. The original call was GL buffer data it actually reserves this memory inside the GPU, and then we make two calls into subdata for the vertices and for the colors, and these two things are now populated